The law of sines and the law of cosines. Breaking rocks in the hot sun. I fought the law and the law won. I fought the law and the law won. By The Clash. 80s punk. Gotta love it. Anyway, let's talk about the law of sines. So the law of sines can be used to find side lengths and angle measurements for any type of triangle. Basically, you have to know the measurements of two of the angles and one of the sides. So as long as you know any two angles and at least one of the sides, you can solve for that triangle using the law of sines. So, if triangle ABC is lengths A, B, and C, representing the lengths of the sides of opposite the angles with measures A, B, and C, then the sine of A over A equals sine of B over B, and the sine of C over C equals C. Whoa, look out. Okay. So, here we are with the, you'll notice angle A is in red here. That matches up with the side opposite. So we always go with the sides that are opposite. Oops. I got the wrong color. There we go. Alright, so we always want to match up with the side opposite, right? So as long as I know, let's say I know angle C, I would match that up with segment AB, the one in green. Okay, so we always match these up with the side that is opposite us. So let's do some law of sines example problems, and this will make more sense. Alright, so we want to solve for x to the nearest tenth here. So I'm going to match up the 21-degree angle with x and the 97-degree angle with 16. So we're going to set this up as the sine of 21 over x is equal to the sine of 97 over 16. Now, you can convert these into values if you wish and then solve from there, or you can just do it all at the end after doing some algebra. So I'm going to do it all at the end. I'm going to show you a little algebra here. So the first part, I'm just going to cross multiply these. So I've got sine of 97 times x is equal to the sine of 21 times 16. So the first thing I'm going to do is I'm going to divide everything by the sine of 97. Right? So now I've got that can cancel here. These will cancel. So we're just going to rewrite everything. So x is equal to sine of 21 times 16 all over the sine of 97. So I pull out my handy dandy calculator at this point, and I go ahead and multiply, and I plug all that in, and I end up with 5.77695. So this is approximately, and since they want us to go to the nearest tenth, we're going to round up, and this is going to be about 5.8. Okay, here we want to find x. We want to round to the nearest tenth. So I'm going to match up sine of 45 with x. Well, here's a little issue. I don't have a measurement here. So I've got to figure it out. Well, I know that 45 plus 73 is equal to 118. So I know that this angle here is going to be 62. We got to do a little setup beforehand. So now we're going to set up our law of sines. So the sine of 45 over x is equal to the sine of 62 over 10. So we're going to cross multiply again. So I get the sine of 62 times x is equal to 10 times the sine of 45. And I'm going to divide now. And I can cancel. And I'm going to rewrite. That's what I like to do. So I got x is equal to 10 times the sine of 45 over the sine of 62. So let's go ahead and plug that into our calculator. So 10 times the sine of 45, oops, that's 45, and we're going to divide that by the sine of 62. And we end up with 8.00848. So we're going to round it to the nearest tenth. And since it's 8.00, this is approximately equal to 8.0. You'll notice I keep that 0 there. And that's because this shows, hey, I rounded to the nearest tenth. If I had just gone 8, that would be rounding to the nearest whole number. So 8.0 is the showing that, hey, we rounded that to the nearest tenth. Okay, now let's talk about the law of cosines. The law of cosines can be used to find side lengths and angle measures for triangles where the law of sines cannot be used. Now you remember, I needed 2 angles. So we use this when the law of cosines to solve a triangle if you know the measures of 2 sides and an included angle or all 3 sides. Okay, so let's go through this. Okay, so if triangle ABC has lengths A, B, and C representing the lengths of the sides opposite the angles, which with measures A, B, and C, then A squared equals B squared plus C squared minus 2BC cosine of A, B squared equals A squared plus C squared minus 2AC cosine of B, or C squared equals A squared plus B squared minus 2AB cosine of C. That's really kind of confusing, isn't it? So let's simplify this a little bit and try to have it make some sense. Okay, so here we have our triangle. Let's say that we know the following things. We're going to say we know A, and we're going to use this symbol theta. That's what they use in Algebra 2 with trig to show that we know that angle. We don't know what it is, but it's a variable they use to show an unknown. Okay, but we're just going to use the variable. And we're going to say that we know this angle, or this measurement, and this one. X and Y represent those two. So you'll see here, we have a situation where it's a side, angle, side, right? So that's what's given to us there. All right. So here's how we can do this. Okay, so if you remember, it says the side opposite. So let's say we're looking to find this one. We don't know that measurement. So here's a way I'm going to help you figure that out. I know these three, okay? These are my three I know. I got 1, I got 2, and I got 3. So I got 2, I just got 3 parts. 2 sides and an angle in between. Now, here's what we got to do. So let's say we take a look at this, and we can say, okay, we know that the question mark squared, I don't like the way that looks. Okay, so the question mark squared equals one side squared, x squared, plus the other side squared, y squared, minus 2 times xy plus the cosine of theta. Okay, so we're just taking these in. We're going to square this. Okay, so let's go back with this. We're going to go with this. We're going to put a square there for that. We're going to put a square there for that. And we're going to multiply, so squared, x squared plus y squared minus 2 times x times y times the cosine of this angle. Okay, so let's do some problems, and maybe it'll make a little bit more sense as we work along. Okay, so we don't know x. So we're going to say that we're going to plug this all in again. So we're going to say x squared equals 9 squared plus 11 squared minus 2 times 9 times 11 times the cosine of 28. Okay, so I'm going to plug all of this here into my calculator. All of this here is what's, oh, excuse me, oh, wrong thing. I didn't want to show all that. This is what I want in the calculator. Just this here. This is where we're just going to plug all this in. So, take my calculator. And I've got 9 squared plus 11 squared minus 2 times 9 times 11 times trig function cosine of 28. And I find out that 27.17, so x squared is equal to 27.1764 on my calculator. Alright, well, I am going to take the square root of this. Of 27.1764. And I've got 5.2131. So x would be approximately, rounding to the nearest tenth, 5.2. Let's do another one. Alright, so now I want to find the value of that angle. So I'm going to plug everything in. So since this is opposite, this stays by itself here. 8 stays by itself there. So 8 squared equals 3 squared plus 6 squared minus 2 times times 3 times 6 times the cosine of x. So we're going to go and do as much simplification as possible. And this isn't really that difficult here. We're just going to isolate this part here using algebra. So we're going to get this by itself. Right? Let's simplify things. So I've got 64 equals 9 plus 36 minus 36, right? 2 times 3 is 6 times 6 is 36 cosine of x. So now we're going to do is we're going to 64 equals 45 minus 36 cosine of x. Now, subtract 45 from each side. I'm having some brain fart this morning. 19 equals negative 36 times the cosine of x. So, 19 divided by negative 36 equals the cosine of x. Okay? So, if you remember, to find the angle measurement, when we don't know when we try to find that, it's cosine of negative 1 now of negative 19 over 36 is going to tell us what that is. That's going to be the value of that angle. So, now if you remember, cosine of negative 1 is just the inverse cosine. So, we're going to take the trig function and we're going to find the negative cosine and hit enter. And then I put in negative 19 divided by 36. And I hit enter. Boom. And I got 121.855. So it's going to be, x is going to be approximately, because we're rounding to the nearest tenth, 121.9. Okay, you're going to have to do this, so we'll work at it. Okay. Okay, so we're going to use the law of cosines, excuse me, because we don't have any angle measurements, so we're going to use that to solve this. So we're going to start with A here, and we're going to go to the opposite, right? So 15 squared equals 12 squared plus 13 squared minus 2 times 12 times 13 cosine of A. We're solving for A. So this ends up being 225 equals 144 plus 169 minus 2 times 12 times 13 is 312. So minus 312 times the cosine of A. And this is all, you need to be doing this all on your calculators. That's what you want to be doing. You want to be doing this all with calculator. So 144 plus 169 is 313. So we want to subtract 225 minus 313. And we end up with negative 88. So negative 88. Oops, I don't want to do that yet. So negative 88 equals negative 312 cosine of A. So we're going to divide each side by negative 312. I end up with 88 over 312. Right? Negative divided by negative is positive, equals the cosine of A. Well, we're going to take the negative of this, right, the inverse of the cosine. We're going to switch those around. What that allows us to do is this situation right here. Right? We can switch these two by going A and that by using the inverse cosine. So, oops, hold on a second. All right, so the cosine negative 1 of 88 over 312. I'm not going to bother reducing it. Let the calculator do that work. Is equal to A. So I go and I plug that in, and I end up with 73.6173. And that is, so A is approximately 74 degrees, because we're rounding to the nearest tenth. So, this is 74. Now I only need to find one more angle, and then I can I don't have to worry about finding the other one, but I can just subtract that other, use the triangle angle sum theorem that the angles have to add up to 180, and I can solve for the third one that way. So let's go back and do this again now. 12, we're going to go with angle B, so we're going to go right here. So I've got 12 squared equals 13 squared plus 15 squared minus 2 times 13 times 15 times the cosine of B. So I'm going to go ahead now and square these, and I get 144 equals 169 plus 225 minus 2 times 13 times 15. Oops, where do I get that? So 2 times 13 times 15, 390 minus 390 times the cosine of B. Okay, so 144 minus 169 minus 225 gives me negative 250, right? I'm doing all that on the calculator. So minus 250 equals negative 390 cosine of B. So negative 250 over negative 390. Divide that by each side by the negative 390. So I end up with 250 over 390 equals the cosine of B. So again, we're going to switch those around. So I'm going to end up with negative cosine of negative 1 of 250 over 390. And that's going to give me an answer for B. So we go ahead and plug that in. Trig function, cosine negative 1. Hit enter. Now plug my numbers in. 250 divided by 390. I hit enter. I get 50.1317. So angle B is approximately 50 degrees. So here's 50. So 50 and 74 is 114, or no, 124, excuse me. So 180 minus 124 is 56. And a good way to check your answers is take a look. The biggest angle should be across from the biggest side. The smallest angle is the smallest side. So that's how you know all your numbers should be in pretty good shape. So final note, we use the law of sines when we know one side and at least two angles within a triangle. And we use the law of cosines when we know one angle and two included sides of a triangle, or no angles in all three sides of a triangle.